two overseas speakers as per their AICT norms.
Sir.
One is you and other is Bipin Balian. One of my friends from South Africa. Two overseas
अच्छा हाँ
और सभी लोग इंडस्ट्री से मेधा
Good evening, sir. Once the participants join, we will start soon.
नहीं आप स्टार्ट कर सकते हो कोई नहीं
Okay, sir.
आप स्टार्ट कर दो पार्टिसिपेंट आपस में कनेक्टेड रहे उनको मालूम चल जाएगा तो तुरंत ज्वाइन कर लेंगे इंट्रोडक्शन और ये सब
Recording in progress.
Sure, sir. A very good evening to all the eminent dignitaries and enthusiastic participants connected with us today. On behalf of Rajkiya Engineering College, I, Medha Saxena, extend a warm and respectful welcome to all the dignitaries, distinguished speakers, faculty members, and enthusiastic participants. It gives me great pleasure to share that today marks day 2 of the 6-day AICTE approved Atal Faculty Development Program on Emerging Trends, UAV aided Next Generation Wireless Communication. We are delighted to continue this academic journey with the same spirit of learning and collaboration that we witnessed on day 1. It is my honor to introduce the distinguished speaker for today, Professor Akshay Kumar Rathore, Department of Electrical and Computer Engineering, National University of Singapore. Professor Rathore is an IEEE Fellow and an internationally celebrated researcher in the domain of power electronics, electric motor drives, multi-level inverters, wide bandgap device applications, and future energy conversion systems. His contributions have shaped modern power electronics technology with extensive publications in top-tier journals, international collaborations, and recognitions across the globe. We are truly privileged to have him with us today to enrich this FDP with his expertise and perspectives. With great respect, I now request Dean of Academics from Rajkiya Engineering College, Kannauj, Dr. Arun Kumar Singh sir, to formally invite our esteemed guest for his technical session. Sir, the stage is all yours.
Sir, it's my pleasure to invite my good friend Dr. Akshay Rathore ji. You mentioned Abhay Rathore, basically he is Dr. Akshay Rathore. Sir, I welcome you in this 6 days FDP program. Your expertise will definitely be beneficial to all of us.
Yeah, thank you, Professor Arun, and happy to contribute. Can I start now?
Yes, sir, yes.
So I will just share the screen and can you see the screen?
Yes, sir, it's visible.
अच्छा ना हाँ and now full screen now full
Yes.
screen
हाँ, sir.
and slides are moving.
Yes, it's also moving.
Okay, yeah, that's all. Because many times there are complaints that slides not moving also, so I make sure initially. Yeah, so good evening everyone, and I am told to speak on power management in UAV systems. So I come from power electronics background, so I will be happy to give some directions about what kind of power electronics are used basically and what are the reasons behind. Okay, so all of us know basically that UAV means unmanned aerial vehicles. I need not to say, this is just to start. And these are driverless basically. So they operate autonomously and controlled either remotely, that is one thing, or they are already have a guided algorithms inside, so they make their own decisions. Okay, so it is like an aircraft, also known as a flying robot. Okay, I mean, application is more or less similar. Robot also either need instructions from you, or it has a guided algorithms inside, and then it makes decision accordingly. So without any human pilot, these drones are flying. So these are like a small aircraft actually. Okay, but driverless, no human pilot. So either we control remotely from the ground from some base station, or any algorithm that we have basically implemented that will guide them accordingly. Okay, so either by ground operator here, or by autonomously by onboard computers with the guided algorithm that has been implemented. Okay, the major applications are military surveillance. It can be on the borders. It can be inside some suspected areas. Okay, so this is just to keep an eye basically and know the present conditions. Okay, nowadays you might have seen it is drones are used for photography also, to make the videos, to make 3D photographs from distance to cover the major crowd. Okay, and another is to monitor the environment, knowing the environmental conditions like humidity, temperature, wind speed, etc. at different locations. Okay, then those datas are stored, and those datas are basically useful for the research and development. So drones are helping basically, your UAVs are helping us collecting data at a particular location, especially in difficult weather condition or challenging atmosphere or environment. They help us collect data and we can continue our R&D. Okay, yeah. So either it is autonomously guided by algorithms that we implemented by AI, machine learning, something in the onboard computers to make decision, or if it is controlled by ground stations, then there is a communication link settled or set up between the ground station and the flying robot, the aircraft. Okay, now here is the setup, that what is inside. Okay, so one thing is clear, that since it is flying, it is basically moving or propelling from one point or one coordinate to another coordinate. It means it has speed. Okay, it means it requires motor and it requires power supply. Okay, yeah. Okay, so in terms of power supply, you can see basically here battery, which is most common that we study. Okay, and another is basically fuel cells. Okay, fuel cells, you know that it can be hydrogen based, or it can be ammonia based. Okay, but hydrogen is more popular because of no emission. And another is battery, because battery is easily available, while the hydrogen is not easily available. So battery always the major source of energy. Okay, for either you drive electric vehicle, either it is a electric aircraft, or it is just a small drone, flying aircraft or robot. Okay, so majority of the power source is basically battery, and fuel cell can be used as a range extender. Okay, yeah. So since it is battery, so it is bidirectional power converter, DC to DC, and then here you have a DC motor. Okay, usually brushless DC motor. And since it is a fuel cell, then the converter is unidirectional, single side directional, and then connected to DC, DC to DC converter, and then it is giving power to the motor. Okay, so either battery alone is giving power, or either both of them are giving power together. Okay, yeah. Okay, another possibility in addition to fuel cell and in addition to battery is the solar. Okay, so for example, here we can put some solar panel which can give you, suppose for example 20-30 watt. Here you can put another solar panel that can give another 20-30 watt. Here can be another solar panel. So altogether you can try to make, for example, 60 watt, 90 watt, 100 watt. Okay, and majority of the drones, which are basically for light load applications, surveillance, photography, environmental conditions, they are usually in the power range of 200 watt to 500 watt. They are not too big. Okay, so because of that reason, you will see that 100 watt is quite significant solar. Okay, yeah, 100 watt is quite significant. So that way, what is happening that solar is basically continuously giving power to the UAV. Okay, so this way it can increase the your what should I say mileage, which is basically it can survive for long. Okay, so you are either charging the battery through solar in a kind of power management, or you are not using the battery, but you are using the solar power for the propulsion or for the speed or for the velocity of the drone. Okay, so this is the benefit. That way you can keep your battery alive for long before you charge it again, and then the drone can continue or UAV can continue. Okay, yeah. So usually, since it is a drone application, so the purpose is to use basically lightweight and high efficiency solar. Okay, so usually the solar panels, silicon based available in market have low efficiency and their density is low. So we do not prefer to use
Mostly,
it. Okay, the solar panel, the solar panel which are used are basically CIGS or GAS, okay, gallium arsenide. Okay, but still, since you are basically it's in open area in the sky, okay, then weather dependence is an issue. For example, if it is raining, okay, or heavy snowfall is there, then basically solar power is not available. Okay, then what happens? Either battery or fuel cell will again come into picture. Okay, so basically this power management is taking care of the power supply from this DC bus to the load, which is motor. Okay, now this power management circuit will decide, is it coming from solar, is it coming from fuel cell, is it coming from battery, or is it coming from the combination of the two, or it is coming from the fuel cell and solar is charging the battery. Okay. Now, when we talk about batteries, so again, I said that basically the batteries should be very lightweight and high density because the space inside the drone is very small. And since drone is basically flying above Earth, so then it should be very lightweight. Okay. So that battery can take the payload for long time and then battery can survive for long. Okay. So usually we always try to use the lithium ion batteries because lithium ion batteries are basically the high density as well as lightweight, although the cost is high. Okay, or lithium polymer batteries. Okay, but lithium ion are the most popular. Either it is electric vehicle or drone because the important thing is the weight and density, volume, not the cost. Okay, yeah. Another, because in any case, if batteries are heavy, then you are basically increasing the weight of the drone UAV, and then it will require more recharging, and then it will require more replacement of the battery, and then overall cost remains the same. So majority of the researchers, whenever they use that, should I use lithium ion or lead acid? Because lead acid is cheaper. Always they do basically techno-economic analysis. That okay, let us do techno-economic analysis for 10 years or 5 years or 20 years. And based on that, they see, okay, if I need to replace the battery, if I need to recharge the battery multiple times, if I need to do the battery maintenance, then the cost involved is very high compared to purchasing a lithium ion right away from the day one. Then possibly lithium ion is better overall for the long run. So techno-economic analysis helps. Okay. Fuel cells basically has very high reliability, very high reliability. So if whenever you want to basically take the UAVs for higher altitude, then hydrogen fuel cells really help because they really can supply the peak power instantly. Always battery has this problem. Battery cannot provide you a peak power instantly. Okay. So if you want a really a peak power instantly to go to a higher altitude, fuel cell can do that. Okay. IC engines comes into picture when it is a very large UAV, almost like an aircraft, one or two people are sitting, or you are basically using it for to suppose in some areas you want to throw some food material, some materials to wear for the people who have been suffering from flood, etc. Okay, so then the weight is increasing inside the UAV, right? They suppose blankets, food, or any other things, right? So it requires more space and it weight is increasing. So then fuel cell batteries may not be sufficient, and they try to go with general IC engine, which is used in general aircrafts or the charter planes. Okay, yeah. So generally fuel cell battery solar, and then in the last case basically IC engines in case it is a larger plane and that is used for basically supplying things for the nucleus things. Okay, so now here from this comparison you can see the lead acid batteries was used in the past, and you can see the lead acid battery has basically here means density is also less and weight density is less. It means for the same power the lead acid battery will have high weight, okay, and as well as high volume. But here you can see lithium ion basically in 1 kg it can supply 200 watt hour rather than this is only 40. It means 5 times less weight or 5 times more power in the same weight compared to lead acid. And here you can see 50 versus 350. It means almost 7 times. So in 1 liter or for the same volume, that it is basically 7 times more, supplying more power 7 times more. So suppose what happens that if you want to use a drone either lithium ion battery or lead acid battery, then lead acid battery will require 7 times more space, and it will be basically 4 or 5 times more heavy. Okay, so since the requirement in the drone is basically lightweight and high energy density and low maintenance, okay, reliability should be high. So lithium ion batteries are used. Okay, and they are quite modular. You can just scale them up in order to increase the value of the power, or replacement is easy. Okay, but batteries, I mean, people who wants to use batteries, they really need to think of many things. Okay, whenever they want to design battery capacity, always it is very important. You might have seen that movie Mission Mangal, right? So this was the major challenge, that if the satellite has to survive for these many days in that climate, in that much of distance from the earth, okay, for these many days, hours basically, then how the capacity of the battery, solar, everything has to be calculated. Always determining accurate capacity is very important, and accurate capacity does not come directly by checking that okay, this battery can give you basically this much of velocity for these many hours and you directly calculate. No, environmental conditions are very important. Speed is very important. How you discharge the battery, what is the speed of the vehicle, the speed of the drone UAV is very important. Okay, so from here you can see, okay, similar to mobile battery or similar to electric vehicle in case of drone. So whenever you are designing the battery, then with designing the battery capacity, you can see if you want to deep discharge the battery. Okay, so suppose rather than discharging for less and then charging it, if you discharge it very deep discharge, then your battery life goes down. Okay, if you discharge it by 50%, it has a 3000 cycles. If you discharge it by 90%, it has basically 1000 cycles. It means the battery lifetime will be reduced by one third. Okay, so either the battery basically survives for 30 days or battery only survives for 10 days. It's like that. Okay, so accordingly you have to take the battery capacity when you calculate that, okay, what will be the deep discharge battery, and after that you will charge the battery through environment, through wireless charging, through fuel cell, through solar or something. Okay, yeah. Okay, another is basically temperature. The drone, in which area the drone is the drone is in Rajasthan, Tamil Nadu, Andhra Pradesh, where the temperature is 43 to 48 degrees, or the drone is basically in Himachal Pradesh, or the drone is in the Jammu Kashmir, where the temperature basically goes to, say for example, -5, -10. Okay, so from here you can see that as the temperature decrease, okay, the capacity of the battery decrease. Okay, you can see, suppose choose any rate. Suppose you are at a constant speed, the drone is running at a constant speed. Okay, and the battery capacity is always determined at 25 degrees centigrade. It means the battery will give you full mileage 100%. Okay, but suppose you are in Jammu Kashmir, Himachal, the temperature is -10. Then you can see the same one, if you see from this curve, okay, will give you 75% mileage only. It means 25% is lost. So if the drone is in Rajasthan, Andhra, or Tamil Nadu, or if the drone is in Himachal Pradesh and Kashmir, you have to increase the capacity on those cold areas by 25%. Okay, by 25%. In addition, you can see in the cold climate condition, the battery life is better. But as the temperature increase, then battery life reduces by half. It means if the battery we are using in Rajasthan, this is 35 and this is 45. Okay, if the battery life at 25 degree is basically when we are using in Kashmir, for example, if the lifetime of that battery is for example 1 year, then if we are using in Rajasthan, Tamil Nadu and all, where it is 45 degree, the lifetime instead of 1 year, it will become basically 3 months, reduced by one fourth, half by 10, another half by 10 degree, another half by 10 degree, means one fourth. So instead of 12 months, battery will survive only 3 months. Okay, so drone does not mean drone. It depends basically where the drone is deployed actually. Okay, where the drone is deployed. So accordingly, you have to choose the battery capacity. Accordingly, you have to choose basically, you have to be ready for the replacement of the battery. That now that is called predictive maintenance also. Reactive maintenance, predictive maintenance, that you are predicting based on this environmental condition that how long the battery will survive, and then you need to replace, and the drone will not work or UAV will not work. Okay, another thing is basically this discharge, deep discharge of the battery. Okay, so this is for voltage, so probably I will avoid this. This is for battery charging, discharging. Yeah, here it is more important, the freezing part. So what happens that suppose if the battery state of charge, okay, if battery state of charge is 100%, okay, battery state of charge is 100%, then battery minus 8, yeah, here if the battery state of charge is 100%, then battery can basically survive in the environment in the temperatures up to -58 degree. It is written a fully charged battery, the electrolyte, the acid inside the battery will not freeze up to -58, means it can survive in the extremely cold climate. But if your battery is coming to discharge, suppose -10, sorry, suppose 10% charging left, then you can see even in -8 degree temperature, the battery electrolytic will freeze and battery won't work. It means the battery will not supply power to the motor and the drone basically will fail down. Okay, so it is very important that if the drone is in very cold climate, somehow you have to make sure the battery is not doing deep discharge. Battery is very close to full charge. For example, if it is 80% charge, it can survive up to -40. If it is 40% charge, battery can survive up to -30. 60% charge can survive to -25. Okay, if 80% charge, then it can survive to -15 also. It's like this. Okay, okay, so this is very important that if it is very cold climate, then the drone will not even fly because the acid inside that will freeze based on the state of charge. So state of charge and temperature are quite related with the freezing of the acid or the electrolyte. Okay, yeah, so all these things we need to take care. Now the next thing is basically fuel cell, which is supplying the battery. So fuel cell becomes very important also because it is as a range extender, and whenever the fuel is not supplying, sorry, the battery is not able to supply power, then we have to completely rely upon the fuel cell. Okay, now fuel cell condition, you need to fuel cell, you should be careful that in case of fuel cell, when you, because the fuel cell is also connected with the power converter DC to DC, and the battery is also connected to power converter DC to DC. One good part about DC to DC is, one good part about the battery is, when the battery is fully charged or battery is coming to discharge to supply power to the load, because when we are giving power to the motor for the drone to fly, the battery will start discharging, because you are taking the power, taking the charge, right, current. So current basically. So what we see is that in those conditions, the battery voltage will not vary much. A fully charged battery, suppose, has a voltage 48. If the battery is discharging, that its voltage will be around 42, 41 volt. It means you will mostly see that when battery is charged and battery is discharged, the variation of the battery voltage is approximately 13%. Approximately 13%. But in case of fuel cell, it is different. If fuel cell is supplying full power, then you can see it is very close to 10 ampere. And when the battery is not supplying any power or supplying only 10% power, suppose here, then you can see the battery, which was, sorry, the fuel cell voltage, suppose this is 40 or 400, then it becomes very close to 800 or 80 based on the number of cells. So you can see that if the fuel cell is supplying the full power, the full speed of the drone, then it is having low voltage. And where it is supplying basically less power to the drone, when the drone speed becomes less or it becomes steady at a particular point to visualize something, okay, to take photo, to visualize something, it is steady, then you can see the voltage becomes double. So since the battery voltage variation is only 13%, but fuel cell voltage variation is 100%, 40 to 80. Okay. And another thing is that when the battery is fully charged, it is supplying full power, its voltage is high. Supplying less power, voltage is less. But in case of fuel cell, it is different. Supplying high current, the voltage is less. Supplying low current or low power, the voltage is high. Okay. So the DC to DC converter you design for the two are different. Okay. And another thing we need to take care is that, suppose based on the in the battery, you do not care. If the drone is at full speed, it will take power it will take the current from the battery, whatever it wants. Okay. Suppose it wants 5 ampere current for some velocity, it will take 5 ampere. But in case of fuel cell, it will be different. Suppose if you want 5 ampere, then basically you have to reduce the fuel flow. Sorry, where is it? Yeah. This is 5 ampere. If you need 8 ampere, then you have to increase the fuel flow. If 10 ampere, then you have to increase the fuel flow like this. Let me show you here. So 10 ampere, suppose this is the fuel flow. For example, 1 liter per second of fuel. Okay. Now approximately 7 liter, 0.7 liter second per fuel. Now it is 0.5 liter per second fuel. Okay. So based on the speed, you have to adjust the hydrogen fuel flow. So it requires a different kind of control system. The battery does not require that control system. Okay, we are talking about power management. Battery does not require that control system. For any speed, if battery wants 5 ampere, will take 5 ampere. Needs 10 ampere, will take 10 ampere. But for 10 ampere, you have to increase the hydrogen flow. For 5 ampere, you have to reduce the hydrogen flow. For 2 ampere, you have to further reduce the hydrogen flow. If you do not do that, then basically you will result into waste of hydrogen, and your hydrogen storage inside the drone is gone, and then you are helpless again. Always in air as well as in the water, in the ship and the drones and aircrafts, saving the fuel is always very important, right? Rather than wasting it. Okay. So that's how another control system comes into picture in case of fuel cell. Based on the speed, you have to adjust the hydrogen flow. And this is not the case with the battery. In case of battery, voltage variation is very small, but in case of fuel cell, voltage variation is double. In case of battery, it supplies high power at full voltage, low power at low voltage. But here, it is high voltage for low power, low voltage for high power. So that's why the design of the powertronics of the two is different. Okay. Another thing is that battery has the capacity to absorb the ripple. But in case of fuel cell does not accept or is very sensitive to input current ripple. So in case of fuel cell power converter, if you are if the input filter is not small, if input filter is not of a good quality, okay, if input filter is not of good quality, Okay. So what happens that in case of fuel cell, you can see if the fuel cell current ripple is like this rather than like this. Okay. Then what happens that we have to adjust the hydrogen flow according to the peak. And from this curve, you can see that if ripple is less, then you can see fuel cell utilization is almost close to 100%. If ripple becomes 20%, rather than 5%, then hydrogen utilization is around 85%. Means 15% hydrogen is wasted. If fuel cell ripple is 50%, then you can see 40% hydrogen is wasted, utilization is only 60%. And if the ripple further increase and the converter is operating into discontinuous conduction mode, then you can see almost 50% utilization, means half of the hydrogen is wasted. It means if the drone is supposed to work basically for around suppose 1 month, then the drone will only work for 15 days. Okay. Yeah. So somehow deciding the capacity depends upon various factors. Okay. So it is not that you can accelerate anytime, you can basically go into any temperature condition anytime. These things are very important. Which temperature condition you are in. Okay. What is the speed that decides basically the fuel utilization, that decide basically the battery performance. Okay. Yeah. So this is the overall picture. So you can see the hydrogen tank. Okay. Supplying power to the fuel and fuel through the boost converter, because fuel cell voltage is low. Boost converter, DC to DC converter, increasing the voltage and then giving power to the motor. Okay. Here we put inverter in case inverter basically in case it is a large size drone, then we use the AC motor. But if it is DC to DC, you don't require this one for low UAVs. Then you don't require it. Is just simply giving power here, and this is BLDC motor. Similarly, solar photovoltaic boost converter and giving power to the motor. Battery bidirectional, giving power to the motor. Okay. Either you through solar you can charge the battery bidirectional. Through fuel cell you can charge the battery bidirectional, or you can wirelessly recharge the battery. You can come down a bit on the ground and then charge and then fly again. Okay, so this is the overall picture. So power management comes into picture that okay, after this overall the motor is getting power from which source. It will vary daily. It can be one, it can be two, one plus one. Okay, yeah, yeah, that's what I was saying. Power management. So most of the time most of the time we are either using boost converter that I have just shown, because you require output voltage higher than input, or a buck boost converter. Okay. Sometimes it happens that you are using a battery voltage a bit high, then motor voltage is low, or battery voltage and the fuel cell or solar voltage is low, battery voltage is high. So then basically sometimes you need voltage gain, sometimes you need to step down. Okay. So either boost or buck boost. Generally, we don't use buck because our output voltage is higher in that case, because are not connecting multiple batteries to increase the voltage level. We are not using a very big fuel cell because hydrogen storage is a problem. And solar photovoltaic voltage is already very less. Okay. Yeah. So we will use this converter mostly. And in this converter, sometimes people use interleaved converter, boost interleaved, buck boost interleaved, in order to increase the efficiency. Because already so far we were talking about the weight and density, but right now another important thing is that how you utilize the power. If efficiency is high, then you are using basically full power, losses are less, then you can utilize the battery charge more. Okay. Yeah. So sometimes already we are using a high efficiency converter, but interleaving helps you in increasing the efficiency, as well as synchronous rectification, synchronous DC to DC helps. So another one is basically boost converter, another is synchronous boost converter. So I will explain this also later. Okay. So these are the power converters used basically here. Here you can see this one. Okay. So either they are boost converter or buck boost converter, either interleaved boost converter or synchronous boost converter. Okay. Yeah. Okay. So what is interleaving? Interleaving means two or more identical converters are connected in parallel and they are sharing the power. Okay. The purpose is to increase the power level, or purpose is to share the power level. So interleaving means, suppose you have designed one converter and you have used it for one drone. Now you are using a bigger drone in terms of size. So two converters you can interleave, and instead of 200 watt, now you can supply 400 watt. Okay. Yeah. And you can see it can result into ripple cancellation that will reduce the filter size. And I just mentioned that in case of fuel cell, filter is very important. So it is like this: a fuel cell or battery is here, and this is suppose a DC to DC converter, and sorry, this is wrong picture, and suppose here is motor. Okay, so this is one DC to DC converter, and this is another DC to DC converter. So what is happening, that power between the two is shared. So for example, if a single converter is supplying power, then the current is basically through that converter is I. Now, if two converters are supplying power, then current between the two is I by 2 shared. Okay, I by 2. Now, if we see what will be the losses will be basically I square R. So that will becomes I square by 4 multiply by overall resistance that is coming into picture. Okay, and multiply by 2 because there are two converters. Okay, so you can see what will be the overall will be basically 1 by 2. This 2 basically divided by this 2 and 4 will make it half, and then it is I square R. Okay, so compared to, you can see if you use 1 unit and if you are using 2 units, so because of the current sharing, okay, the losses becomes 1/4 and then multiply by 2 converter. So overall the losses becomes half. If overall losses becomes half, means overall the heat generated due to the losses will become half and the cooling requirement will go down. And overall the losses has become half, it means efficiency will increase. If efficiency will increase, then means better utilization of the battery charge as well as the hydrogen of the fuel cell. Means if efficiency is high, losses are less, then the for same value of hydrogen storage and same value of battery charge, the drone can survive for long. So you can see by using an interleave system how you can basically do the power management better for the better mileage of the drone. Okay, yeah. Another thing I was sharing, that talking about the filter reduction due to the ripple. So you can see if this is the ripple current of one cell and this is the ripple current of another cell, and you can see both are shifted by 180 degrees. So then you can see the overall ripple is this at the input side. This is converter 1 ripple, converter 2 ripple, the current, and this is the ripple of the input, because they are causing basically ripple cancellation. If ripple cancellation happen, then the good part is that input filter requirement will go down. Okay, so filter size will reduce, and as I was telling you before, that fuel cell requires input like steep DC current, right? Like this, for better utilization and better efficiency. Otherwise, half of the hydrogen is lost. So we don't prefer like this ripple. So you can see interleaving is helping you. Interleaving is giving you this kind of input current. Sorry, the single cell, but interleaving is giving you basically this kind. Okay, so it is satisfying your fuel cell requirement as well as it is reducing the filter size. So you can see interleaving is giving you two benefits. It is giving you basically high efficiency, better utilization of the battery as well as the fuel cell hydrogen, as well as it is reducing the filter volume, that will again reduce the volume and cost as well as the density, the weight of the drone. Okay, yeah. So that's how this overall we try to satisfy the density, lightweight, and reliability requirements. If you have multiple sources, solar, fuel cell, and battery, then reliability is better. At least you are having one source to supply power, and lightweight and high density through interleaving systems, as well as through basically the I mean, we will discuss more how it is. Okay, so you want to make it light density. Okay. So high frequency basically results into compact and lightweight system. Why it happens? Because nowadays, if you will see that people who are using high frequency power converter, the major purpose is basically to make the system very compact. and lightweight. Okay. So how it is done? Through the high frequency. So that's why the people are using basically megahertz, kilohertz or kind of frequency. Okay, that is reducing the size of the transformer, that is reducing the sizing of the inductor, magnetics, filters, capacitors. Mm. Okay, so if you want to use high frequency switching, then the high frequency switching basically is done by different kind of semiconductors. So if you want to use high switching frequency, then nowadays the trend is used to use gallium nitride device, which is one of the wide bandgap device. Okay, gallium nitride. So if you will study a bit about it, you will see that the gallium nitride device is very small and surface mounted device, and the gallium nitride basically has very low resistance that makes basically high efficiency. Okay. Earlier, people were using basically silicon devices, but silicon devices are basically not making it. Okay, so here you can see that the power converter that we are talking inside, the DC to DC boost converter, synchronous interleaving, its volume becomes very important after we decide the sizing or the capacity of the fuel cell, solar, and the battery. So you can see that the majority of the volume inside the power trans is taken by the transformers, inductors, filters, and capacitors. Okay, and here are the semiconductor switches, the gallium nitride or silicon devices. Okay, so now how to reduce basically the inductors, transformers, capacitors, filters. So the solution is this one, high frequency. Okay, because the value of transformer turns, the value of the inductor value L, the value of the capacitor, they all are basically inversely proportional to the switching frequency. If switching frequency is high, then number of turns as well as the value of capacitance inductance will go down in the same ratio. If basically switching frequency is 10 kilohertz or it is 100 kilohertz, the value becomes 1/10. If it is megahertz, then further reduced by 1000. Okay, so that's why from large inductor to small inductor, large transformer to small transformer, large capacitor to small capacitor has been accomplished by using high switching frequency. And high switching frequency you can use, but your device should be able to handle it. Okay, so gallium nitride devices are able to basically handle very high switching frequency. So now you will get the benefit of a small transformer, a small inductor, a small capacitor, okay, and a small size filter, and then you will get this high density, lightweight, and compact power supply for the drones. Okay, but the problem is, another problem is heat sink. Heat sink is basically the part coming from the losses. You can reduce the losses by interleaving, that we already mentioned. That by doing the interleaving, you can reduce basically the power losses. But those losses are basically the conduction losses when the devices are conducting. But whenever the devices are switching, this is turn on and this is turn off. Okay, the device voltage going down and device is started conducting the current, and this overlap is called turn on loss. And when you are turning the device off, current is going down and then voltage starts rising across the device to charge the device capacitance, it is turn off. So this is turn on loss, this is turn off loss. So this plus this is called basically switching loss, and then you multiply it by the switching frequency, because it is not happening one time, it is happening basically for you can see here it is happening for 100,000 times, with this 10 to the power 5, 1 megahertz time 10 to the power 6, based on the switching frequency you have adopted. Okay, so that switching losses will increase and basically make the devices hot, and then you will have basically cooling requirement, which is basically this heat sink. Okay, so now by using high switching frequency, you have reduced the size of transformer, magnetics, inductor, filter, cores, capacitor, etc. But you have increased the heat sink size. Okay, so in order to reduce that heat sink size, then we have to adopt basically soft switching. Okay, soft switching means we have avoided the overlap during turn on, overlap during turn off. Then switching losses becomes zero. So this is called zero voltage switching during turn on and zero current switching during turn off. Means first voltage goes to zero, then switch starts conducting, or the current goes to zero, then the switch starts blocking. So once the switching losses becomes zero, then you are basically free to increase the switching frequency to any limit of kilohertz and megahertz, that is through the gallium nitride device, and then the heat sink size will be reduced because switching power losses has been reduced. Okay. So now so now then things becomes ideal that by using interleaving, uh, you are reducing the conduction loss, and by using short switching, you are reducing the switching losses. And altogether efficiency can be increased to the maximum value, the optimized. Okay. So then it comes question, we can get the short switching. So short switching can be done by different ways. One is by choosing a proper switching strategy, turning on and turning off, which is known as PWM, pulse width modulated converter. Another is by using the auxiliary circuit. Okay, that if you want to turn the switch off, then you first divert the current. That is called zero current transition. Divert the current to some external circuit. Or when you want to turn the switch on, you basically discharge the capacitor of the switch by external circuit. So this is called transition circuitries. Another is resonant converter, that you have to use basically this tank, LC tank, in series or parallel, or series parallel by increasing the number of LC tanks. Okay, short switching, because then current will take this shape, sinusoidal shape, and you get short switching basically, turn on and turn off, resonant converter. Okay, but as we already see, the resonant converter means we are first already thinking that how to reduce the volume, cost, and weight of the converter. If you start putting inductor and capacitor, then the volume will increase. So then resonant kind of short switching is not good for the drone application. Whenever we talk about electric vehicle charging, whenever we talk about solar inverters or fuel cell converters for UPS, backup power supply, etc., then we talk about resonant converters. But when it comes to drone, already we are trying our hard to reduce the transformer, inductor, capacitor filters by increasing switching frequency. Now you do not want to take the risk by adding the resonant tank, and then again you come back to your previous situation again. So resonant converter is not an option for drones. Generally, the first option is the best. That by choosing a proper modulation, pulse width modulation strategy to turn the switch on and off, how best you can reduce the switching losses. Okay. Yeah. Okay. Now, when we talk about, so these are some issues basically. You see the resonant tank. That's what I was saying, that we should avoid it. And the resonant tank is not coming directly. When you put the resonant tank, you have to optimize the tank kVA rating so that the tank size LC is very small, especially for the drone. We are already reducing them through a high frequency. You cannot add. Optimize the gain, okay, so that current should not increase. If gain is low, then current will be high for the same power. Low voltage, high current for the same power, or high voltage, low current for the same power. If low current, then efficiency is better. Okay, so you try to optimize the gain. You want to reduce the RMS current through the switches so that the losses can be reduced, as well as you want to reduce the frequency variation. Okay, too much frequency variation is also not good for the filter design as well as for the device's health, the lifetime. Okay, so these issues comes with the resonant converters, and we do not want to go with them. So only the solution for drones power converter is pulse width modulation. Okay, yeah. So just choose a proper switching strategy, turn on and turn off, that can optimize the switching frequency at its best. Okay, yeah. Now power converter. So interleaved we have discussed already, and now we are discussing this switching losses reduction through short switching. And not only switching losses, but high frequency is also adopted in order to reduce the volume of transformer, magnetics, filters, capacitors, etc. So now through high frequency you reduce that. Through short switching you reduce the heat sink size. So now the weight and volume has been reduced. Okay, by interleaving efficiency has been improved. Now we are using basically this converter that I will show you. Okay, so the first one is boost converter and the second one is synchronous boost converter. Nothing much difference, only difference is that this diode is replaced by the switch. And why it is done? Generally, in case of drone application, brushless DC motor, this generally this voltage is in the range of 12 volt to 18 volt or something. And here the motor Depends upon the sizes of the drone. It can be 40, it can be 18 volt to 48 volt. Okay. So maximum is 48 volt generally. So now this diode, the diode that you are selecting is basically the rating of this diode is either 60 volt or 70 or 80 volt. Same thing will be for the switch, either 60 volt, 70 volt or 80 volt. Because see, when the diode is on, the diode voltage is zero. And when the diode is off, the switch is conducting. Then what is the voltage across the diode through Kirchhoff voltage law? 0 plus V naught is appearing. Same thing here. When the switch is on, voltage is 0. When the switch is off, this switch is conducting. And what is the switch voltage? This 0 plus V naught. Same thing for this also. When this switch is conducting, the voltage across the switch is 0. And when this switch is conducting, what is voltage across this switch? This 0 plus V naught. Same thing for this switch. When the diode is conducting, the voltage across the switch is 0 plus V naught when switch is conducting 0. It means rating of all the switches and the diode, whatever it is. In case of boost, it is diode. In case of synchronous boost, it is the switch. Okay. So it is V naught. So we will use basically around 80 volt device or 80 volt diode. So why this synchronous boost is used, you can do this quick calculation. Suppose output voltage is 48 volt. Okay. And if it is 500 watt, then say approximately the current is 10. So 10 multiplied by 48 is 500 watt. Okay. Now if there is a diode voltage, okay, if you are using the diode, then what is the power loss in the diode? 1 multiplied by 10, which is 10 watt. And this is the diode basically when you are using a slow diode. But if it is 1 megahertz efficiency, and if you are using basically Schottky diode or basically fast diode, then it becomes around 2 or suppose 1.5. Usually it becomes 2, but suppose 1.5, then it becomes 50 watt of loss, 15 watt of loss. Okay. But if you are using synchronous boost with MOSFET here rather than diode, if you are using a switch, then what is the loss in MOSFET? The loss in MOSFET is basically I square R. Okay. And what is I square R? I square R means 10 square multiplied by resistance of the MOSFET. What is resistance of the MOSFET is basically 3 milliohms. This is from a practical data sheet. Okay. So what will be the losses? The losses basically will be 0.3 watt. So you can compare 10 watt or 15 watt versus not even 1 watt. Okay. So that is why basically when we talk about low voltage application, in low voltage, instead of using the diode or instead of using the normal boost, we generally use synchronous boost, because synchronous boost converter will give you high efficiency, because the MOSFET losses at low voltage is less than the copper.
Children joyfully celebrated holidays, Kannada Rajyotsava, Children's Day, Raksha Bandhan.
Okay. So this is I square R, again same 10 ampere is passing. So 10 square multiplied by 3 milliohms will become 0.3 watt. And diode, if it is 1 volt drop, which is basically for low frequency, and 1.5 to 2 for high frequency, then you can see around 15 to 20. You can see the losses. You can see the losses. I mean 15 or 20 versus 0.3. That's why we do not use this one, but we use basically synchronous boost converter whenever it is for low voltage or light drone applications. Okay. And then the power management. Okay. Yeah. Now, of course, then despite everything, you are using basically high density drone so that the payload is less. You are using all the battery characteristics I showed you, the fuel cell characteristics I showed you, and you try to optimize the efficiency. You are in a better environment, and you are using interleaved converter. You are using high frequency. You are using synchronous boost. Everything is done, but still at some point of time battery will discharge. Okay. Then there are multiple ways. Either basically battery will come and do the charge basically through some power line. Okay. By resonant coupling, magnetic resonant coupling, it will charge itself through a power line, transmission line. Otherwise it will come down a bit and it will slowly charge through the this wireless signals coming from these data for communication systems. Okay, that you can see in this picture. Or in the ground there are some stations. Okay, so drone will reduce its altitude and then you can see the this microwave transmitter is basically is generating high frequency signals. Okay, and then the antenna of the drone will catch it and then will charge the battery. Okay, the distance depends upon basically the frequency of the microwave transmitter or the antenna. Okay, but you have to basically come to that particular zone where the microwave antenna or transmitter is there. You have to come in that zone, reduce the altitude of your drone, and then charge your battery through this antenna, and then again fly high. Okay, so this way you can you need not to come down, plug in, and then charge the drone, but it can be charged through a transmission line. It can be charged through a communication network. It can be charged through microwave transmitters. Okay, through antennas. Okay, then it continues. Yeah, so that is all. I hope I tried to cover the maximum possible aspects from the source to characteristics of battery fuel cells, high efficiency, losses, soft switching, and synchronous boost rather than normal boost that is used, and yeah, and power management through between the different sources, how to charge the, how to survive for long using different sources. Okay, so that is all from my side, and I will be happy to answer any queries now.
Thanks, sir. Now audience can ask any queries or any question which they find that it will be related to the topic as covered by the Dr. Akshay Rathore ji. Or you can post your queries in the chat box. We will ask on your behalf.
Yeah, I'm also putting my in case later on somebody wants to approach.
Sir has saved his email ID. So if anyone can ask question or any query, then they can also mail to this mail ID.
Yeah, I mean, if today they do not have, I mean, we'll take Q&A, but in case of anything, we'll be can approach later also anytime for any work.
So there is one question from KB Singh. Why do engineers use gallium nitride devices instead of silicon devices?
No, silicon devices
For
cannot
high
even
frequency?
yeah, silicon devices cannot operate into megahertz. That's why we need to use gallium nitride. This is the semiconductor characteristic. So silicon carbide devices have their limitation. They can operate up to some hundreds of kilohertz. But later on, we have to switch to gallium nitride device if we want to megahertz, because this is a semiconductor characteristic. Gallium nitride device is like a wide bandgap device, and when you read the semiconductor physics, then you will see that because of higher bandwidth, 3 times more of electron volt, then they are able to basically switch at 3 times high switching frequency. And so that's why. And another thing is that the capacitance of the gallium nitride device is less than the capacitance of the silicon devices. So since the capacitance is less, and because of that, the switching losses will also be reduced in the gallium nitride device. So that's why the gallium nitride devices, due to their semiconductor characteristics, can go into megahertz region. And because of that, they are used over silicon. Silicons are also for some hundreds of kilohertz. Yeah, I had mentioned that if you remember that, let me share it again. Interleaved. You can see the screen now, right? Yeah. Right, you can see the screen now?
Yes, sir.
Uh-huh. Mhm. So, yeah. So you can see interleaved. Suppose just think of only two. Suppose two are interleaved. If we have only one converter, so that converter is suppose carrying current I, then the losses will in that converter will be basically I square R. Right? R with the resistance, suppose overall resistance coming in series. Okay. And if they are basically two, then for the same power, they are taking current is shared half and half. So then it becomes I by 2 and I by 2. Then the losses in the converter, overall losses becomes I square R. But what is I? I by 2. So it becomes I square by 4 multiplied by resistance and then multiply by 2 because there are two converter. Earlier one converter, so I square R. Now I by 2 square R and then multiply by 2, two converter. So this 2 gets cancelled with this and you can see the overall losses in the interleaved converter becomes 1 by 2 I square R, which is half of this. Okay, so that way by doing the current sharing, you can reduce the conduction losses to half and that increases the efficiency. And in another case, you can see that by interleaving converter, you can see that the ripples are cancelled. So this is the ripple of one converter, ripple of another converter, and then basically this is the overall ripple at the input. And if the ripple is less, then basically it overall improves the hydrogen utilization, resulting into better mileage and efficiency, end-to-end efficiency. Okay.
If there is no query, then we can end the session and rejoin at 7:20 or 7:25 for the next session. So I once again thank you to and thankful to Dr. Akshay Rathore ji, who kindly accept our invitation because I know that he is too busy and he just come from the China. So once again, thank you, sir, for joining and presenting this
No, thank you
intricacies
very
of the power requirement of the UAVs because it is a pure technical presentation. I think it will solve many of the queries of the person who are working in the designing of the UAVs. So once again, thank you, sir.
welcome. I mean, happy to contribute a bit, although it is very minor. So that's why I shared my email ID in case later on, if anybody has any queries and want to discuss or ask, we'll be happy to respond from power electronics, power management, and characteristics of different sources and energy management point of view. So I think quite a lot of attendees. I can see 60 plus. So I thank you all the attendees for listening to this session and coming. Thank you.
Only, sir, this is around because 175 are registered candidates are there, but at a
Oh.
time only 65 are there.
Hmm.
So it is, although it is
Still a
less
lot.
from my point of view, but
Hmm.
anyway, it is
Thank
good
you.
number.
Yes.
Thank you, sir.
Thank you.
Medha, you can ask participant to rejoin at 7:20. So this now it is 20-minute break. Okay. Thank you. Thank you. Welcome.
हा पाणी झालंय. मग ते काय कोणाला सोडणार आहे ते काय
हाँ, हो रही है। Good evening to all the eminent dignitaries and participants connected with us today. This is session 4 of the 6 days AICT approved Atal Faculty Development Program. It is my honor to introduce our distinguished speaker for the session, Mr. Ankit Bansal, a highly accomplished data science and quantitative research professional with over 10 years of experience in machine learning, deep learning, Gen AI quantitative trading, and financial research. Mr. Bansal is currently serving as the Chief Technology Officer at Innovative Financial Management LLP Delhi, where he has developed algorithmic investment strategies, real time trading automation systems, LLM powered financial analytics, and equity portfolio optimization frameworks. We are honored to have with him today and look forward to an engaging practical learning experience. With great respect, I now invite Mr. Ankit Bansal to deliver the technical session.
Thank you. Thank you. Let's just wait for 1 or 2 more minutes to so that more participants can join.
अब अपने वहां पे बोला ना तू झूठ बोला किसे सीखा तूने झूठ बोलना मैं शादी जैसे त्रिविधा लेकर उसकी तरफ
Good evening, everyone. Today, we'll explore the financial viability of the UAV or drone industry and what challenges it faces. My goal is to simplify everything. So, even if you're new to drones, don't worry. By the end of this session, you will have a clear, complete understanding. So, what are drones? Basically, drones are UAVs, which are basically unmanned aerial vehicles, and you can consider that as a simply a flying machine with no pilot sitting inside, right? It's controlled either by a remote or software that flies it automatically. The key elements of UAVs are frames, motors, batteries, sensors, and a small computer that tells it how to move. We use drones to take photos, inspect buildings, spray crops, deliver goods, and even for defense. If we talk about that, why they matter, because they have very high efficiency of doing those things which are risk at for the manual work. They are at very low risk. They are repeatable and they can give us very accurate data. They are easily scalable. If we talk about that, how UAVs have evolved, so basically it started from the military for the military purposes many decades ago. They were used mostly for the surveillance, re- reconnaissance drones. They are very that time the very high budget R&D were being used for the UAV technology, and then they also started for the autonomous guidance. Then the commercial purpose or the commercial sector has been evolved by the UAVs in 2005 to 15, where the consumer drones have been introduced for photography. Drone racing has been there, and for the people who wants to create the content. And the main reason for this is because of the price drop in the sensors. Then after 2015, the UAVs has also become intelligent. They can avoid obstacles, they follow GPS routes, they can make decisions using AI. So the drone industry is moving very fast from simple hobby toys to serious business tools. If we talk about the types of UAVs, then there are multiple types. Mainly, there are three types. First one is multi-rotor drones, which are stable and easy to deploy. They're ideal for mapping and inspection. You can think of multi-rotor drones which have four or more propellers, and these are very common type of UAVs. Then there are fixed wing drones. They have they look like small aeroplanes and they can fly longer distances. That's why they have long endurance and they are used in surveying and border security. Then we have hybrid UAVs. VTOL is basically vertical takeoff and landing, which contains the best of both multi-rotor drones and fixed wing drones because they have vertical takeoff and long flights. You can consider these as a helicopter that can fly like an aeroplane. Lastly, if I talk about the classification of UAVs, then DGCA, which is the Directorate General of Civil Aviation, has classified the UAVs in five categories based on their weights. Nano, which is less than 250 gram, micro, which is 250 gram to 2 kg, small from 2 kg to 25 kg, which is most commercially used, then medium from 25 kg to 150 kg, and very large, which has more weight than 150 kg. The DGCA, if you know that it's basically India's National Aviation Regulatory Authority, the government body that makes rules for everything that flies in India's airspace. Think of DGCA as a traffic police plus licensing authority of the sky, right? Now, if we talk about the global UAV market, the global drone market is growing very fast, around 20 to 25% every year. The market valuation in 2024 for UAV market is 30 to 40 billion dollars, and this is expected to cross $100 billion by 2030. The main reasons for this that industries want automation, government want better surveillance for the safety and security purpose. Government companies want faster inspection methods. The world is about to cross 100 billion by 2030, right? Defense still spends the most, but the commercial usage is also growing even faster. CAGR for UAV market is expected 20 to 25% every year. And as I mentioned, that defense still leads globally, and commercial services are now expanding faster even than the defense sector. Any questions up till now? Okay. If we talk about the Indian UAV market, the India's drone market outlook is 3,000 crore currently, and it's expected to cross 50,000 crore by 2030. India is becoming a very important drone market. This is mainly because the government has introduced policies that support drone manufacturing and drone services. India is using drones for land mapping, agricultural spraying, infrastructure inspection, and many other areas. The market is expected to grow nearly 15 times in the next 5 to 7 years. The main expansion in Indian market is mainly because of the cost advantage in manpower, manufacturing and software, because we have very cheap labor, right? If we talk about the expansion of the drone industry in India, then that's also because of the government push, which is which has brought PLI and drone policy 2021. What is a drone policy 2021? So basically, under this policy, in this policy, the government has reduced the paperwork and made it easier for companies to manufacture and fly drones legally. This has enrolled unrolled the major uh, complications that at the time being. PLI stands for Production Linked Incentive, meaning the government gives financial incentives to drone manufacturers, or you can also say the subsidies. This is helping Indian companies grow faster. If we talk about the OEMs, which is the original equipment manufacturers of the drones, so this type of policies and PLI schemes gives OEMs a very high boost and helping Indian drone industry increasing with a faster rate. As we talked about the drone classification by DGCA based on the weights, but there is also different classification based on what on a different structured framework, which decides what permissions are needed, what airspace restrictions are applied, and what pilot certification is required. Because for each kind of category, for each category of drones, there are different things which are required. Similar, just an example, the nano drones, which has weight less than 250 gram, required no DGCA certification. But if we talk about the small drones, which are 2 to 25 kg, which are majorly commercial purpose drones, they require UAOP and RPC. Now, if we talk about what is UAOP and RPC, so UAOP basically means um, you can think of it as a um, license for a company to operate drones. Okay, it ensures the company follows safety rules. It has proper operation manuals. It has trained pilots. It registers its drones. It flies only in allowed areas. It's basically is a company getting permission to run a taxi service, right? But for drones. So that's what UAP does. If we talk about RPC, RPC is basically remote pilot certificate. So this is for the human pilot. So this is needed certification as per the DGCA for running the small drones. And this is mainly for the human pilot. If the drone flies autonomously, a certified pilot must supervise it. RPC ensures the pilot knows Indian air laws, safety procedures, how to control the drone, and emergency handling. RPC is like a driver's license, but for flying drones, right? Okay. Any questions up till here? Okay. Let's move further. If we talk about the regulatory requirements in India, we can see that to fly a drone commercially, a company needs multiple type of certifications or identifications. So few of them are a registration number for the drone, which is UIN. Like we have a registration number for any vehicle running on the road, right? Then UAOP, permit for operating in commercial tasks, like the taxis, the commercial taxis has to take a permit to run in the different cities and states, right? Similarly, a certified pilot, a digital permission before every flight, because they have to disclose that where they are going and they are not going into any restricted zone. So there is also airspace zoning adherence, which are green, yellow, and red. India also uses a system called NPNT, which is no permission, no takeoff, digital clearance. You must have heard of in or maybe watched in many movies or series that whenever an unidentified helicopter or aeroplane is going some in another country, they have to take a permission to land there, right? This is similar to that. This ensures safety and prevents unauthorized flying. If we talk about the BVLOS policy landscape, so what is BVLOS? BVLOS is basically beyond visual line of sight. This allows drones to fly far away where the pilot cannot see them. So up till now, it's not permitted. The current status is still that trials are ongoing. It's not fully approved because, but once permitted, drone deliveries will become financially viable and long distance operations will also be able to sustain. The financial impact of BV loss will be the cost per delivery can be reduced by 60 to 80%. It will enable zipline type operations at a scale. If we talk about the revenue models in UAV industry, so there are multiple models being used in the UAV industry. The first one is hardware manufacturing. In hardware manufacturing, so we'll discuss all these revenue models in detail. Next one is drone as a service, then SaaS and analytics platforms, then training and certification, component sales like batteries, payloads, and data monetization like GIS, action analytics. So drone can make money in many ways, in all these ways, by selling the drone itself, or by offering drone services, by selling software, or by selling drone data. Most profitable part is actually the data, not the drone. And it's very shocking point, right? The drone is just a tool to collect the data and the but the most but the most money making is in the data itself, not the drone. And we will see it how. So if we talk about the hardware sales model, selling drones like physical devices brings money, but margins are very low because many companies can manufacture drone hardwares, right? Also, hardware companies need to spend a lot on R&D and testing. So hardware alone is not the best long-term model. It though have direct revenue and it has a high demand in defense as well, but it has very low margins because there are so many players in the market. And as we have mentioned that it requires a very high R&D and certification cost as well. Plus, China also has a cheap labor like us, so there is a direct competition with China as well. And China is also a very large manufacturer. Now, if we talk about the drone as a service, then here this is the most popular model in India, especially in agriculture. Instead of buying drones, farmers or companies hire drone operators who charge per acre, per flight, or per kilometer. This creates recurring, stable income for drone companies who are providing drone as a service. So if we talk about agricultural spraying, mining surveys, the companies who are into mining, then solar panel inspections. So the companies who are providing solar panels and giving the maintenance of the solar panels, they also use drone as a service. The financial benefit of this model of drone as a service is that it's a recurring revenue and it's a fast payback period. You can get the complete investment in 3 to 12 months. Next, if we talk about the SaaS and data monetization model, it's a highest margin business model. So highest margin business model means that you're buying it very low and you're selling it very high. So the profitability is very high. That's why it's known as highest margin business model. This is where the real money lies. Companies upload those drawn images to the cloud, then software turns them into maps, 3D models, and insights. The same software can be sold to many customers, so profit margins are extremely high, right? Because once the drones have collected the data and it has been turned into something useful information, then same information can be sold to many clients or many companies. So the same information is being utilized multiple times or is being sold multiple times. These data can be orthomosaic maps, 3D models and point clouds, NDVI analysis, asset health scores. If we talk about the orthomosaic maps, those are basically drawn maps. So you guys must use Google Maps, right? But consider that a drone which is giving very high resolution stitched together map created from many overlapping drawn images, right? Like it's like taking 1,000 photos of a field and joining them into one big perfectly aligned map. That's a orthomosaic map. It's useful because it has very accurate measurement. It is up to date land information, and it is being used in agriculture, construction, mining, and mapping. Orthomosaic maps are far more detailed than Google Maps. Now, if we talk about the 3D model and point clouds, so a collection of million of tiny points in 3D space captured by a drone using photogrammetry is basically a point cloud. Each point has an XYZ coordinates representing the shape of the object or the structure. If we talk about the 3D model, then a digital replica of buildings, land, mines, etc. are being created from the point clouds and 3D models. The drone takes images, software converts them into millions of dots. Dots are stitched into a 3D model so that you can rotate, measure, analyze it. It's being useful for infrastructure planning, mining volume calculations, construction progress, and asset inspection. The NDVI analysis is basically crop health mapping. NDVI basically stands for Normalized Difference Vegetation Index. So a drone uses a special camera to check how healthy plants are, which takes a manual labor to maybe many hours. A drone can do it in within few seconds. Healthy plants reflect more near infrared light, but unhealthy plants reflect less. That's how a drone can use the technology to get the information about the crop's health. NDVI converts this information into a color map, which tells that if it is green, it is healthy. If it is yellow, it's moderate. If it's red, it's unhealthy. It's useful to detect crop disease early, water stress detection, fertilizer planning, and precision agriculture. If we talk about the asset health scores, it's basically a numerical score showing how healthy an asset is, right? It includes asset could be any hardware like solar panels, power lines, wind turbines, buildings, pipelines. So asset health tells us that how healthy that asset is or that building or solar panel is, right? And how is it done? The drone images capture the images of the assets. Then AI analysis is being done by identification of cracks, hotspots, rust, vegetation, growth, and convert them into a health score. It's being used in the predictive maintenance, reduce breakdowns, optimize repair budgets, and plan inspections. This model also is very much profitable because of zero cost of replication. As I've told you earlier, that once you have done this, you have created a model or you have created a AI insight, then that same model can be used for multiple clients. And AI models can also automate the insights. So it's completely automation basically. So no intervention of the manpower. If we talk about the logistic and delivery economics, the current delivery drones can reduce this cost significantly. A bike normally delivers in 18 to 25 rupees per kilometer, but a drone can do it for as low as 7 to 10, 12 rupees per kilometer, right? Though it's BVLOS because it's beyond the visual line of sight and it is still not allowed, but once it will be opened, it will open a whole new path to the drone industry. The advantages are the direct flight path, no traffic delays, and lower operational cost. But the biggest barrier is that BVLOS permission is not yet fully active. If we talk about applications of the sectors, in agriculture, it is being used for spraying and imaging. In infrastructure, it is being used in construction monitoring. In energy, it is being used in power lines, pipelines, solar inspection. In defense, ISR and tactical drones. ISR is basically surveillance. In media, content creation, or you might have seen filming. Then disaster management for evacuation and post disaster mapping. So drones in UAV industry is being used in so much sectors right now. If we talk about some agriculture use cases, then agriculture is one of the biggest drone applications in India right now. Farmers can spray pesticides using drones, which can save 40% time in 40% time. It is also 6 to 8 faster than manual spraying and 85 to 90% savings in the water if we talk about the liquid sprays. Farmer can spray pesticides using drones, saving time, reducing chemicals, and improving crop health. Drone can complete work in 10 minutes, what a manual labor will do in 1 to 2 hours. So that's a very high uh, saving of the time and other other parts. The recurring revenue model, if we talk that it takes only 350 to 500 rupees per acre spraying. Why UAV is being used in agriculture so much? Because of the government subsidies and the labor shortage in rural areas. If we talk about the infrastructure and mining, then drones can quickly scan mines, right? It can measure stockpiles or inspect construction sites as well. This reduces risk to human workers and provides accurate 3D models for planning. The companies can finish a 3-day survey in a few hours. That's how fast drones can become in infrastructure and mining. It reduces the risk for the workers and it's highly accurate for 3D digital twins. If we talk about the drone industry in energy and utility sector, then you can see that drones are very useful in solar farms, wind turbines, and power line inspections. They save downtime, do predictive maintenance using AI, and provide higher grid reliability. In defense and surveillance, everyone knows defense is one of the highest value drone markets. Drones help with border surveillance, scouting, and tactical operations. Countries are heavily investing in drone swarms and long range UAVs as well. What are these? Let me take you through that one by one. We know that in defense, surveillance is very much needed. So, the tactical reconnaissance basically means collecting the information about an area, enemy, or situation, usually before making a decision or taking an action. If we talk about long endurance fixed wing UAVs, then those are basically a drone shaped like a small aeroplane that can fly for many hours without landing. If we talk about it the fixed wing UAVs are basically kind of an aeroplane which flies straight for a long time using very little energy, and they also have a sensors and cameras. They have wing based lifts like an aeroplane, which saves battery. They can fly long distances around 30 to 200 kilometers as well. Altitude can be high, thousands of feet, and they are used for continuous surveillance or mapping. Now, fixed wing UAVs are fly longer than multi-rotor UAVs, because multi-rotor drones are with 4 to 6 propellers, but they constantly push air down to stay in the air, right? So that's why they take high power consumption. But fixed wing UAVs don't use propellers; they use wings, which uses very low power consumption, and thus their flight time is very high. If I talk about the swarm drones, then swarm drones is a group of many drones that fly together in a coordinated manner, like a flock of birds being controlled by AI. You must have seen many times in the sky that many pigeons sometimes make a group, right? And then they constantly monitor an area or roam around in an area. Similar to that, swarm drones are also based on the same concept, that it's a group of many drones that fly together and controlled by AI. If you want to think it like an 50 to 100 tiny drones, very tiny drones, all flying together, understanding each other's movements and completing tasks as a team without crashing into each other as well. That's a swarm drone. They are very coordinate. They have a very high coordinated movement. Their decision making is AI driven. They are fast, scalable, and adaptable. They have no single point of failure. If one drone fails, the rest continues. Now, these are being used in defense for attacking enemy targets in waves, overwhelming defenses, surveillance with multiple viewpoints. In agriculture, also, swarm drones are being used to spray crops in the patterns. In searching and rescuing as well, in which they cover large disaster zones simultaneously. For entertainment, drone light shows in which hundreds of drones are there. The swarm drones communicate with each other in real time. They maintain relative positions. They can split into subgroups as well. AI assigns tasks to each drone. If I talk about the financial angle, in the defense, it has a very high margin, 30 to 60%. And because of the long-term government contracts, it's very much sustainable. And Make in India push also helps Indian UAV industry to grow at a large scale. Now let's see how UAV works in the media and entertainment industry. This is the most visible use of drones, right? They are used for weddings, movies, advertisements, and live event coverage. This market is easy to enter, but it has very low margins. The FPV drone racing is also one of the case here. FPV is basically first person view. So FPV drone racing is a sport where pilots fly high speed drones using goggles that show live video feed from the drone's camera. It feels like you are sitting inside the drone, flying it like a virtual reality game. Imagine wearing VR goggles, right? And controlling a tiny flying race car. You see exactly what the drone sees as if you are riding inside it. And you race through tracks at high speed. That's FPV drone racing. FPV racing drones are very different from normal camera drones. They are super fast. They approximate have 120 to 200 km per hour of speed. They are highly agile. They're built for tight turns and obstacles. They're custom built by pilots and they're manually controlled. No auto stabilization. They are designed for speed, performance, pilot skill, and not for photography. A small camera on the drone sends live video. So video goes to the pilot's FPV goggles. Pilot sees what the drone sees in real time. Then pilot controls drone through tight tracks at high speed. FPV racing is also being used as a sport. FPV racing is now a competitive global sport with leagues like DRL, Drone Racing League, Multi GP, F1 style drone tournaments. Pilots race through courses filled with LEDs, gates, tunnels, tight corners. It's one of the fastest growing tech sport as well. FPV is being used in cinematics as well beyond just racing. For fast and smooth shots in movies, real estates, videos, and ads. FPVs are also used for fast close range navigation in delivery. They are also being used in fly through buildings or tight spaces for the emergency responses. FPV matters in the UAV industry, showing human skill plus tech skill. It pushed innovation in drone motors, batteries, and controllers. It gives rise to high performance drone components. It opened new market, whole new path in cinematic and FPV filming. It also inspires youth interest in robotics and aviation. Now let's talk about the financial viability factors. So we have seen that a drone company becomes financially viable when it has recurring income, high fleet utilization, accept to enterprise clients, BVLOS permissions, AI-based analytics, high-value enterprise clients, efficient maintenance, and software-based insights. Hardware alone is not enough. For any drone company to be financially viable, all these should be there. If we talk about the cost structure and unit economics, drone operations include both capital costs and operational cost, right? So capex components include drone procurement, sensors and payloads, backup batteries, repair kits, and training. While operational costs include data, cloud, pilot salaries, and maintenance. Companies with higher utilization make more profit. If we talk about the capex versus opex in UAV business, then we know that buying drones is expensive. It is very high capex industry, but running them regularly is cheaper because it has low opex. DAS and SAS, which we talked about, drone as a service and service as a service, reduces capex because companies don't need to buy drones, they just outsource. So if there is a hardware heavy business which only does creates or manufactures the drones, so it has a very high upfront cost and it will take long to get payback. So it has a high capex. But for a service heavy business which does not buy drones or manufacture drones, but takes DAS or SAS as a service, then it has a lower OPEX, lower capex. It has a recurring monthly income and it has a faster scaling and it gets the payback in a very short time as well. R&D and certification costs. Making a drone reliable and safe is expensive. Companies must test the drone many times, validate its safety, and get certifications. This takes time and money, but also creates a competitive advantage. Barrier to entry is very high, but this creates a moat also for established players. Let's see some investment trends. Idea Forge IPO was a very huge success, rising Indian defense tech investments. VC's interest has been shifted to AI plus autonomy platforms, and obviously international focus on drone delivery startups. If we talk about all this, then investors are very excited about drones, especially defense and AI based drone startups. In India, IdeaForge IPOs showed strong investor confidence. Globally, companies like Zipline are raising billions for drone delivery. Let's do a case study of a drone company, DJI. DJI is the world leader in drone manufacturing. They control more than 70 to 80% of global consumer market share. They succeed because they manufacture everything themselves, giving them lower cost and higher quality. And they are the very technology leader in this industry. Let's take an Indian case study, IdeaForge. So, IdeaForge is India's leading drone company, mainly serving defense. Their focus on quality and reliability helped them secure government contracts as well. They had a very highly oversubscribed, successful IPO in 2023, showing strong financial trust on UAV industry as well. Their main focus is on long range surveillance. Let's take a case study of the Zipline. Zipline is famous for medical drone deliveries in countries like Rwanda and Ghana. They have completed more than 100,000 deliveries. Their per delivery cost is very low because of long distance BVLOS operations. They use long range, autonomous, fixed wing drones. The UAV industry is also very competitive globally. If we talk about China, which has very high hardware dominance, right? And US, which has AI autonomy and defense. India is also rapidly growing in service and analytics. So each country has their different strengths. If we talk about the technological challenges in drone industry, then drones struggle with short battery life, strong winds and weather, GPS interference, autonomous navigation reliability. These issues limit large scale adoption. If we talk about regulatory challenges, drones operate in the same airspace as manned aircrafts, right? So regulation is very strict. BVLOS is still restricted, certification takes time, and cybersecurity is also very major concern. If we talk about the operational challenges, then there is a very high shortage of the pilots because drone pilots need training. It requires battery health management because batteries degrade quickly. Maintenance downtime is also very high. Training manpower because companies need effective fleet management. Let's see what are the societal and privacy issues. People worry about privacy, right? Drones can capture sensitive images as well. Hence, privacy is a very great concern. Noise, safety, and potential misuse are also key concerns. Public acceptance is important for long term adoption. Let's see some future trends. The future of drones involves autonomy, drones making decisions without human pilots. AI, better batteries, and new materials will allow drones to fly longer and safer. Autonomous drones and AI. AI allows drones to avoid obstacles, follow moving objects, and navigate without GPS. So, this will help drones for real time path obstacle avoidance and collaborative multi drone missions. This unlocks large scale drone operations as well. And since AI onboard processing is also there, the whole new path of drones with AI is opening to the world. UTM systems. UTM basically means unmanned traffic management, similar to air traffic control for drones. It will manage thousands of drones flying simultaneously in the sky. So this needs digital map integration. It will do automated flight approvals. It will also need to create drone corridors, and it will and also it will avoid the network collisions. The drone swarms we have already talked about, but let me take you through with that again. Drone swarms are groups of drones flying together like birds. They are used in the military and can also be used in agriculture or search and rescue. In military, they are being used offensive and defensive swarms. In agriculture, they are being used as swarms. In search and rescue, they are being used as a distributed search patterns. Urban air mobility. If we see how drones are going to use in the long term future. So this is the long term future. Passenger drones or flying taxis, right? Up till now, you have or someone has already only have imagined it that there will be flying taxis, but this is actual going to be a foreseeable future as of now. In next 10 to 15 years, we may be seeing passenger drones or flying taxis, but this will require major infrastructure and regulations, and companies are actually actively working on it. A lot of R&D is going on in this area as well. If we talk about the conclusion and key takeaways, the UAVs are financially viable when tied to recurring services and data analytics, right? Regulatory unlock for BV laws will accelerate the commercial viability. India is at an early S-curve stage where there is a huge opportunity in the drone industry. Investing in economy, investing in autonomy, analytics, and fleet ops is actually the long-term winners. The future will be autonomous and AI driven. India has a very strong potential to become a global drone hub. Regulation is the biggest unlocking factor, which we which many big investors thinking that it will happen soon. And drones are anyway becoming financially viable, especially in services and analytics. Thank you for listening, everyone. I'm happy to take questions. This was all from my side. Thank you, Vijayji. Thank you for listening. Hope you have liked it. Thank you, everyone. I think you must have learned a lot about the UAVs industry with their financial viability as well, the challenges and the upcoming trends in the UAV industry. Thank you, everyone. Just writing that out in the chat box.
Recording stopped.